Today we have two speakers. We have Jed Sundwall and Vincent Sarago. I want to thank you both for taking time and coming and presenting here at the TensorFlow Working Group. Jed is the Executive Director at Radiant Earth. Radiant Earth is a non-profit tech company which works on a number of cloud-native geospatial tools through its different initiatives. Jed will talk about those initiatives. Vincent is the geospatial developer at the development seed. Vincent has worked on a number of open source projects relating to geospatial cloud native solutions. He will talk some of those solutions, especially the Titiler and EO API. So without any further ado, I want to give the floor and mic to Vincent and Jed. Please take it over.
So I'm going to go first. Everybody, I'm Jed Sundwall. Anyway, I've already been introduced. So I just got to find my slides here. Let's see, is this going? Okay, so this should work. Now, so Radiant Earth, we're a nonprofit. We're based in the U.S., but our team is distributed all throughout the United States. I actually live in Seattle. If you go to our website, you'll see our headquarters are actually in D.C., but I'm the executive director of Radiant Earth. I live in Seattle, and our team is actually spread all over the world. Well, from Seattle to Lagos, that is. So we're just entirely distributed team. And we're a very small team, but we punch way above our weight. I would say our work, we see it as creating the data-driven initiatives, services, and 21st century institutions that we need to foster shared understanding of our world. And that's how I characterize our mission. It is to increase shared understanding of our world. And we do that through two main things. We have a thing called the Cloud Native Geospatial Foundation. That's the umbrella under which we do work to encourage adoption of what we call highly efficient approaches to working with geospatial data on the internet. And then a thing called Source Cooperative, which is actually a utility that we're building, which makes it easy for people to publish data on the internet using cloud object storage. And so I'm going to talk to you today about both of those things. And why we think they're important. So first of all, let me just show you Source Cooperative. So it is, if you go to beta.source.coop, you can see it right now. In fact, you'll see here right on the front page, there's a data set, the National Wetlands Inventory, that was published by Qinsheng Wu, who's on the call now. We're in beta right now with Source Cooperative. And so if anyone is interested in using it, you can just reach out to us directly. You can write to hello@radiant.earth and send us an email and let us know if you're interested in testing it out. But I want to give you just like a quick overview of how it works. So I'm gonna at the risk of doing something live, I'm gonna do a live demo really quickly so you can see how Source works. So 1 second. Okay. So we've borrowed a lot of concepts from GitHub with Source Cooperative in terms of it being a place where individuals or organizations can create repositories. And so I'll use Qinsheng's example here as a repository where there is a title, there's a description, you can see who uploaded it, you can see when it was published. We allow tagging of repositories as well. But when you open a repository, you also see a README file. So there's basic documentation at the outset of the file. And I'm not just doing this because Qinsheng's on the call, but like this is an exemplary README file, really well documented data set. And then if you want to actually see the data, we provide just a file browser. It's very simple and very straightforward, where you can click through and you can see the different files that comprise the data set. One way I characterize Source Cooperative is that it's kind of like the file browser for the entire world, or the finder for the internet, where you can just go and look at files. We want to make data available to people and visible to people so that they can work with it. Now, however, what we're trying to encourage is for people to work with this data in programmatic ways. So it's not just like, hey, here's a bunch of files, come download them onto your computer. The expectation is that people will be able to use Python or really whatever, any programming language they want to interact with the data in here programmatically. One other thing that we're working on, and this is somewhat new, is we've open sourced parts of Source. So we intend to open source everything eventually with Source, but we've open sourced what we call the viewer components of it. And so just like with a file browser on your computer, if you click through to a file, oftentimes now you'll be able to see a preview of it. You'll be able to have some kind of preview or quick look of it. We want to do the same thing for certain file formats that we can recognize on the web. And so one of the first things we've done this for is for a file format called PM tiles, which is a cloud optimized vector tile format. It's a really cool one because a PM tiles file, this is about a 200 gigabyte file that contains over 2.5 billion building footprints from around the world. And I can click on this and I can zoom in anywhere in the world, and it will render the mapping tiles, the vector tiles, like quite quickly. And so that was, I actually don't know where that was, somewhere in India. Here, this is Sao Paulo. And I can just zoom in here and it will render quite fast. We want to be able to do this for all sorts of different data types. And in fact, I mentioned earlier, we're actually in New York right now at Columbia University focusing on ZAR and in accelerating development of GeoZAR. In the future, we want to be able to show, if you get to like a ZAR store that's hosted in Source, we want to provide some way of visualizing it if we can. And so that's one of our intentions here. So anyway, that's a quick overview of what Source is. It's just a utility for publishing data on the web using cloud object storage. And I'm going to talk about the importance of cloud object storage as well in a second. So let me go back to my slide. Okay, so that's Source. Now, I've used the term cloud native a little bit before. So for those of you that aren't familiar with the concept, when we talk about cloud native files, we're talking about file formats that are largely read oriented, where the intention is that you are going to publish them one time. We know that's not always the case, but the notion is that the data is fully baked. You have a file format that represents some sort of artifact of research or a product of a sensor or some kind of instrument, and you expect lots of other people to read it. Frequently, cloud native formats will be oriented to support partial reads of files. So for example, in the PM tiles file that I mentioned, that's a 200 gigabyte file. The intention is really not for anybody to ever download the entire file, but instead to navigate through it by reading parts of it as you need to. And that's what it enables, what I just showed off in that demo. Additionally, cloud native approaches should support parallel reads. Frequently, we're talking about pretty large data products. So things that we're talking about, and when I say pretty large, maybe anything north of like 10 gigabytes, it starts to get big enough that you'll benefit quite a bit if you can read it in parallel. And then the other thing is that you want to enable very fast metadata reading of these files. And the reason for that is that when we're talking about the cloud and we're talking about distributed computing, you will not have a file system locally that knows everything about all the data that's out there in the world. So what we need to figure out is, how do we give people the metadata that they need as quickly as possible so they understand how to navigate the rest of the file? If you want a fuller dive on cloud native formats, I really recommend that you go to guide.cloudnativegeo.org. This is an amazing guide. It was funded by NASA Impact. Most of the work was done by Development Seed to produce this guide, and they've just given that to the cloud native community. And so that's at guide.cloudnativegeo.org. You can learn a lot more about cloud native formats. Now, the thing is, this actually has a pretty big impact on how people approach research, science and research, because it allows people to publish data without needing to run a server, without needing to run an API or manage any kind of service to interact with the data. Ideally, you can just write files to an object store and then get out of people's way and let them build on top of it. And we've seen a lot of this happen in terms of people being able to build new tools, new little applications and utilities, libraries, and a very rich ecosystem of different tools at different levels of the stack for people to build on top of data that's hosted in this way. And so that it makes things easier both for the data publishers, and then it frees up data users to build on top of it. And ultimately what this should mean is that research happens more quickly, science happens more quickly, people can develop applications that are bespoke and tailored to their needs more easily. Rather than, if you use other formats that are much more, I guess I would say, overwrought or specifically built for certain software packages, then everyone's locked into those certain software packages. So we kind of want to move beyond that. And in fact, like, this is a model that I use to describe how how we think about these things. So the concept of pace layering is something that came from a guy named Stuart Brand, very interesting thinker, like 21st century or 20th century philosopher, had been very influential in the tech world. But he has this notion of pace layering to describe how the world that we inhabit, it's constantly changing, and the way that we experience it is based on a number of layers that move at different paces. So the substrate that undergirds everything is what we could call nature. It changes somewhat slowly, and obviously we're a little bit alarmed when nature starts moving more quickly than we think it should. But nature's the substrate. We have culture on top of that, governance on top of that, infrastructure, commerce, and then fashion is this crazy thing that happens on top of all those things that moves at a rate that's kind of inscrutable and hard to predict. But the point is that culture moves more quickly than nature, governance more quickly than culture, et cetera, et cetera. So this is a bit of a joke, but I think it actually works pretty well. Is that we agree that nature's the substrate under everything, and then right on top of that is the internet protocol, right? So we have a very fundamental technology that has enabled the internet to grow and to be sustainable over most of my lifetime at this point. And that's a pretty stable technology. On top of the internet protocol is the hypertext transfer protocol. And that's what we use to transfer all information over the web that you interact with with browsers. And then on top of that are standards like file formats and metadata. We've seen this with the web with HTML, JavaScript, CSS. Certain standards have evolved. They evolve more quickly than HTTP. Over time, they might reach some kind of stasis, but the truth is they're still moving forward quite a bit. In the cloud native geospatial community, what we've found is that there are standards like metadata standards like STAC, the Spatial Temporal Asset Catalog, ZAR, Cloud Optimized GeoTIFFs, GeoParquet. These are standards that are optimized to work over HTTP, right? And then this might seem a little bit counterintuitive to some people because you need sensors to produce data that are stored in those formats. But I'd say that the standards ideally move more slowly than development of sensors. If you have a robust set of standards of file formats and metadata, that should enable people to create new sensors and new instruments that produce data about our planet and know how to share them, like know what file formats to put them in. And then if we have all these layers working correctly, that should enable, similar to fashion, a pretty crazy, very dynamic and hard to predict environment in which lots of different interfaces and applications are being built. This is where I want to point out that this is very different from how software has been built and how data systems have been built over the past, well, I guess I would say throughout most of my lifetime, where typically the approach has been to you build software and some kind of proprietary software, you get everybody to use it and buy licenses to use it, they get trained on it, and that software uses one kind of file format, right? And so you're sort of like locked into a file format. What we're doing is sort of flipping that, where we're saying we can actually produce community standards that are open in terms of like, these are the file formats and metadata that we use to share data. If we do that well, that should enable anybody to produce all kinds of like crazy applications on top of it using a lot of different models. So this is where I'd like to point out that there are a lot of proprietary software tools and packages that integrate with cloud native geospatial formats. It's in their best interest to do so. And so I'm not really dogmatic about the licenses that people use or the business models they use to sell their software. We should be open to lots of things. There's going to be commercial SaaS applications. There are going to be little open source libraries at lower levels of the stack that people create. We want all of it. We want to have a very diverse set of applications and stuff being built on top of data that's being shared in this way. And so to frame this, this is how we see our work: is that Source Cooperative is a utility that just makes it easy for people to publish data over HTTP. You would think that would be easy, but it's not that easy for some people. We're just trying to create something that's a very simple tool that allows people to publish data over HTTP. And then in the Cloud Native Geospatial Foundation is where we experiment with how do we motivate communities to continue developing these file formats and standards in the open, and how do we drive adoption of those standards. The other thing I'll point out here is that our approach is largely focused on how we create technology rather than what the technology is. So there are a handful of cloud native standards out there now, and there's a lot of community momentum behind them, and they're probably going to stick around for a while, but we also anticipate that things are always going to be changing. And so what we want to do is try to figure out how do we operate in such a way that we can be open to new technologies that are beneficial that the community wants, and how can we do this openly and reliably over time, and then also we are explicitly focused on driving adoption of these things rather than saying like, hey, here's a standard, everyone should use it. We want to figure out what can we do to help people learn about it and benefit from it and want to use it. We see that as being an important part of our work. The way that we measure things, and this is ongoing, figuring out how to do this, but we're continually trying to figure out how do we measure just the volume of data that's out there in cloud native formats. How can we measure how many implementations of these formats there are, like in terms of like what software applications are actually using them? Do things work in QGIS? Do they work in ArcGIS? Do they work in Google Earth Engine or other things like that? We want to track those implementations. We want to track the number of people in our community. One of our goals is to create a larger and more diverse community. So to the extent that we can instrument that, we want to count that. And then as well as the number of tutorials, like what kind of educational content is out there, as well as what languages is this content available in. Right now we have a very heavy bias towards English content, and that's partially a function of the nature of our community, which is very heavily biased towards English speakers. We're trying to figure out how to change that and raise money to fix that. Now, this is for people who might be leery of the cloud and big commercial companies holding on to all of our data. I really love this piece. It's a very short blog post by UV Panda, where he talks about how there are freedoms that you have if you're working in the open source world if you use the cloud. And so people get nervous about these hyper-capitalist organizations that run the cloud and getting all their data in there. But there are ways to run data, create data infrastructures in the cloud that aren't inherently tied to any particular provider. And so we can write software and we can develop standards that really work with any cloud. And really any compute environment if we're thoughtful about it. So I really recommend that people check out this blog post. But the point is we seek to figure out ways to build services that can work on any cloud provider, but that you could also run them on any sort of local compute as well. That's our goal. And then this is I'll leave this at one last point about Source is that I created this slide a few months ago because I was sharing with some of the funders for Radiant Earth. And I wanted to get them excited about Source Cooperative. So I was like, okay, I should come up with a slide about Source Cooperative. And I created the slide. And then a few hours later, I came back to look at it and I realized nowhere on this slide do you see Source Cooperative. And I actually was very gratified by that. Is that I wanted to create a slide to talk about this tool that we have. But the point of the tool is that you never see it. It's just going back to the pace layers thing. It's the substrate under all these other things. And so this is the same data set that I showed you before of the building footprints. This was published on Source back in September of last year. And I just love the story that within, just hours of it being published, a guy named, who goes by Postholer online, created a mashup of it. And then Quinn Cheng, who's on this call, he created a few hours after that, another tutorial with open source code that people could use. And then just a few weeks later, someone who we'd never encountered before was able to create another mashup with some UN data and some Bolivian census data. And this is the story that we want to tell. This, again, it goes back to the pace layers thing, is that if we get the fundamental layers right, it should enable lots of people working completely independent of one another to build things on top of the data that they find interesting and that they think is going to be interesting and useful to their communities. And so that's the approach that we're taking. Again, if you're interested in anything that we're doing, if you have questions for me, I'll be around for questions after Vincent's presentation. But you can reach us at hello@radiant.earth, and you can visit our site at radiant.earth. So thank you very much. Oh, look at those hearts and stuff. Thank you, guys. All right. Oh, and yeah, over to Vincent.
Okay, thanks, Jed. I love the source code. It's a great tool. Right, let me share my screen and then share my slides. This one. Right. Okay, so I hope you can see my screen. I'm not able to see you, so it should be good, I guess. Yeah. All right. Okay, so thanks for the invitation first, Biplov, and I'm sorry that it took me so much time to answer, but I'm really happy to be there and to present some of the work I've been working on at DevSeed. And so yeah, today I'm going to talk about dynamic tiling and some tools called Titiler. And so as we said, I'm a geospatial engineer at Development Seed, and my main focus at Development Seed is working on map tiles, and specifically the raster map tiles. So the imagery that you see when you go on Google Earth, on Google Maps, and you switch to the satellite-based map. Basically, you will load map tiles, raster map tiles, so JPEG, PNG, or WebP. Representing data from satellite imagery, from drone imagery, or from whatever data set they had. But basically what you are seeing is small imagery, a small image put on the web map all together. And those images, so the map tiles are usually 256 by 256 JPEGs or PNG. And so, yeah, that's an example on OpenStreetMap. Basically, you see the map tiles loading as you zoom in and pan. And basically, there are two ways to create those map tiles. They are either static, so we'll see in the next slide. So it's you pre-generate all those small files. So yeah, that's an example. When you see the video, it's when you move and you see those map tiles loading. So it's either static or dynamic. Static is you pre-generate all those map tiles, and dynamic you create map tiles once on user request. So static, yeah, you do all the work before the tile is requested on the map client. So you do all the processing going from your original data set, so satellite imagery. You do reprojection, rescaling, map processing on top of the image. You cut all your image in small tiles, and you put all those billions of small JPEG or PNG files on the cloud storage, and then they are accessible to the map client directly, or you via a CDN or a map server. And so that's a lot of work to do, especially if you have a set of a base map that is evolving every week or every year. You have to do that every time, and you have to upload or like have a process that create that on the cloud, and that will like handle billions of files or small files. And some of those files might not ever go to the web client because like they will be in north of Antarctica or whatever, and like people will never request this tile. So you end up having done a lot of work and like having put a lot of tiles on the web object storage, maybe for nothing. And so that's where dynamic tiling is a different approach. Basically, with dynamic tiling, you keep your original data set. You put the data set in a cloud-optimized format, and then put your whole image on the cloud storage. And then you have either a dynamic tiler, like Titiler that we'll talk after. You put a dynamic tiler, or maybe a really smart web map client that is able to fetch only the part of the data that is needed from your original data set to render the style. And so instead of you as a data provider having to decide how to reproject the data, or to rescale the data, or to do the map the map processing on top of your data, you let the user decide. I mean, it's an option. You can let the user decide. So it's then up to the user, to say, hey, I want to display this data set like I want. And so, and this enables a lot of more possibilities than with static map tiling, because like when it's static, the data is there, it's not moving. You as a data provider decided how to represent your data. But with dynamic tiling, it's really to the user to decide how to display the data. So how it works again, you put either a Titiler on top of your optimized data set, and then the service will read the part of on user request. So every time a user or map client requests one tile, it will ask the server. The server will then fetch only the data it needs from the original data set and do all the processing it needs, and then respond with a PNG or JPEG to the client. So this is just an example. You see the tiles loading, and everything is done by Titiler. So Titiler will fetch the original data and then encode the original data in small tiles. And so I say you let the user decide what to do. Maybe your data has multiple bands, like more than 3 bands, like maybe it's an hyperspectral data set. And so the user can then decide which band to combine to get the visual representation of your data. And so that's, again, you don't have to create all the band combination possible beforehand. Like you can just let the user decide what to do. And so that's the real power with dynamic tiling. Like everything is like yet to be decided, like how to represent the data. Same with multiple data sets. You have like a set of data that it's spanning geographically. You can ask the dynamic tiler to merge those dynamically as you zoom in, as you pan on the map. Like the tiler will find all the dataset present for one tile and then merge them like virtually and like create the map tiles again dynamically. So like if you like, for example, for this dataset, it's the Copernicus dam. If you had to create like the static tiles, you might have to like merge all those dams together first, and then to run your process on top of that. And it might be a really long process to do that. While with dynamic tiling, everything is done on the fly with Titiler, for example, and it's really powerful. So again, with dynamic tiling, you can choose the projection you want to visualize the data. You don't have to create all those map tiles in different projection. You just ask the service to display the map or the tiles in different projections. one other aspect is like your data. Maybe it's not an image per se. Maybe it's not a RGB image. Maybe it's like the data type of your image. It's not like bytes. So you have to do some kind of rescaling or math process on top of your data to get a visual representation that you can display on the web map as a PNG. So you can either apply color map or like do some Venn expression and some row scaling. And so this is something that, again, it's really important when talking about dynamic tiling. Is like you can really do a lot of things with dynamic tiling. So this is just to summarize all the things, all those, the thing that is open with dynamic tiling. Like you can select bands, select the projection, select the output format, select do different band math or more complex processing on the fly as the user requests the tile. And you can also access the raw pixel value directly, because you put your data as a cloud optimized data set, and then you can really access every pixels directly. You don't have to keep both the render image as a static tiles and the raw data. You only keep the raw data and you save some space. Yet the dynamic tiling is a bit slower in comparison with static tiling, because the service has to fetch the data and then do the processing and transcript that in an image to send to the client. But so it's hard to compare with static tiling, because static tiling is pretty fast because it just load the file, the small image on the map client. So it's pretty fast and efficient. If you are looking for efficient way to display your data, you should always use static tiling. But if you are looking for a way to enable more features, or more way for the user to represent your data set, dynamic tiling is a nice approach, because you give the power to the user to do whatever they want with the data. And so I've said about talking about dynamic tiling, and what it means, and now I can talk a bit about Titiler. So Titiler is one open source project we work on at Development Seed, and basically it's a Python module built on top Rasterio that helps you create a set of web endpoints or services to create your own dynamic tiler. So you do pip install ttiler.core, because Titiler is a set of modules, and then you can really in a couple of minutes have a set of endpoints running locally, or you can deploy that using AWS Lambda. And then you have a web service with different endpoints to create for that they can access any kind of data that you have on a cloud storage or everywhere. You can either have data that you don't own that is somewhere else on a public bucket, and have this your instance of Titiler or your services reading those data sets and creating tiles from it. So on the left side, just a really simple service that will create tens of endpoints to access your data and to display, to create your dynamic tiler basically. And so Titiler, there are multiple plugins to Titiler that as I say, it's a Python project, and so it's pretty simple to install and to deploy it. And we are always looking for more features to add. So if you have ideas or if you want to try it, and just feel free to open an issue in the Titiler repo, and I'll be more happy to help you with that. I think I have got 5 minutes left, so I'll talk a bit about another project which includes Titiler, which is EO API, so the Earth Observation API. This is something we started to work on last year at Development Seed. And it's basically a solution. So it's an open source solution. It's free. It's not a product that DevSeed is selling, but it's more, again, an open source project where. So we focused on Titiler for a bunch of time, like to create like dynamic tiling, and we also work with the Stack metadata and the Stack database, like to help people like cataloging their own data set. And we also work on the Stack API and like other open source project, like which like with the goal to help people to catalog their data and render the data with Titiler and basically access the data. And so at one point, like they were all those projects, like so Titiler, Stack Fast API, PG Stack database, all like in different way, in different parts. And they were nothing like really for people to bring all those things together. Like, let's say I've got a bunch of imagery. What do I do with those? Like, what do I do to let people like access those and search for those data? Yeah, now you can use Source Co-op, which is a great way. But like, if you want to do on your own, like create your own services, you had to figure out like how to start PG Stack database to store all your and to create all your metadata and store all your metadata in the PG Stack. Then how to connect Stack Fast API, so a Stack metadata service on top of that. And then you had to connect Titiler to render your raster data. So a lot of things. And basically the response to that is EO API. With EO API, the idea is to have everything in one place. So the metadata store as PG Stack, the raster service, the vector service with TPG, another open source project DevSeed is working on, and Stack Fast API. So basically you have like one place where you can like, and we provide multiple ways to deploy EO API on locally or on cloud providers. And so basically, it's a way to combine all those building blocks all together and starting to have a full Earth observation API for your own and to like really access, search, and display your data. And again, we try to only use state-of-the-art application like Titiler, Stack Fast API, PG Stack, TPG to really help anyone to like start like building a real like place where they can like store and start sharing their data and not keep that only for them. And so that's it. I'm always talking pretty fast, so I'm sorry.
Well, thank you so much, Jed and Vincent. Maybe we can start with Q&A. Before I saw someone raise their hand, but there's a question in the chat from Isaac who asks, what's the worst case latency for generating a tile dynamically with Titiler?
The worst case, so I've talked a bit about mosaicing, like when you have multiple data sets spread over different geospatial areas. So the worst thing is that, like, if you have a lot of small files, like really small GeoTIFFs, for example, like spread around the world, and like you want to create one tile at low resolution, meaning that like when you will have to load a lot of files, open a lot of files, like to maybe for each file to contribute 1 pixel in your tile. So let's say you have to open like 250 or like no, more than that, like thousands of files at low resolution. So it's always the difficulty is for people to understand once you have a data set, the data set can only cover one set of zoom level, dynamically at least. You cannot like create like zoom level 0 for your high resolution data that is maybe like 512 by 2000 or whatever. It's a small file at zoom 0, and it's pretty hard to explain for me and for people to usually understand that at zoom 0 you cannot load like your high resolution file, because like you basically are trying to create like something in the zoom 0 tile that is less than 1 pixel, and and when you are mosaicing, you will open like thousands of files and wait for like the tiler to respond to that. The tiler has to go through all those files, and so this is basically the worst case scenario, trying to create like low resolution tiles for like high resolution data.
Awesome, thank you. Chuseng, I see you have a hands up.
Can you hear me?
Yes.
Yeah. Thank you both for the presentation. You two are my heroes. I benefit a lot from you guys, and for Titiler, I've been using it like from the start. So integrate in all my packages, and I appreciate the generosity of Timothy for the Titiler demo endpoint. So my question is maybe for Jed, it is like you guys are doing fantastic work, and so it also provides some of those resources. For example, the demo endpoint and then the source co-op. So for me, I would like to teach users in the geospatial community how to use those stuff. But in the meantime, I don't want people to abuse some of those resources. That, for example, the Titiler endpoint sometimes have some disaster. I saw some app, and then all of a sudden they might increase the traffic, and then increase the bill that people will pay. So I try to minimize that. So specifically for source cooperative, right? So yeah. I know you have some blog posts in the past talking about the business model, how it's run sustainable. So I was wondering if you can tell a little bit more about that, because I really want to teach people to use. But I haven't like put out a video like how you can use it, how you can create a repo, how to upload stuff. I'd love to, but I don't want to overload you that somebody has to pay the bill eventually. Right. So how do you make sure that it's sustainable, that we can, it's great, but I want people to use it, but how much you can, you can take it now at the moment?
No, I mean, I'm glad you asked this question. I think it's important. This is something, you know, I didn't say this in my presentation, but like my background and how I got involved in all of this stuff was when I built the open data program at AWS. And we started hosting, you know, we were hosting all kinds of data, and I was in a position where I found that I could, you know, I built a program that it turns out to be a pretty durable program, but where AWS is giving out free storage, and you just kind of have to hope they keep doing that. And it's, you know, I think people have a similar discomfort with like Google Earth Engine. Like, this is really great. It's a very powerful tool that the research community has benefited from a lot. And let's just all hope that it continues to exist. And, you know, same thing with the Microsoft Planetary Computer. You know, I think we're very lucky to live in a world where we do have these huge tech companies that are trying to help. But to your point, someone has to pay the bills. And I think having being much more clear about the business model and sustainability is important. And so one of the things so eventually what we want to do with Source Cooperative is have institutions that are obligated to publish data pay for their storage on Source Cooperative. So right now, you know, governments and universities spend a lot of money to publish data running their own data portals or their own servers and things like that. Our position on this is that sharing data is fundamentally a pretty much solved problem because of cloud-based object storage. So what we want to do with Source Cooperative is have a model that allows people to pay for the storage they need and no more, but also to have flat pricing. So one of the reasons that object storage is scary to a lot of government agencies is, Qiusheng, to your point about if there's a disaster and an endpoint starts getting hit a lot, the bill's going to go way up. And so I think that's something that we can flatten out. So what I'd like to do is say, you know, it's going to cost $10 a month or $10,000 a month, depending on the volume of data that people want to store, but they never have to worry about variable data transfer costs. that's where we want to get, and we're still figuring out the pricing for that. But for now, it's in beta, and everything's free. And just to be very transparent, we have an agreement with AWS that gives us free storage and bandwidth right now for open data, and so we're going to keep, so we're still just kind of like another skin on top of the open data program. We haven't solved that sustainability issue yet, but that's where we want to go.
Thank you very much. I hope you will be sustainable. So I would love to continue to use that. It's just great, so much easier than having to upload my own data to AWS or Google Cloud. It's just a one command line. You can upload all kind of data, make it available, and synchronize with GitHub. It's just like, to me, it's a game changer for me. I mean, it makes it easy for me to produce data and also retrieve PM ties and read GeoPacket, like meantime, like teaching workshop. I don't have to worry about people having to be the credential of AWS, how to blah, blah. It's so much easier. Yeah. Cool. Thank you very much.
Glad to hear that. Thank you.
And so I will also answer. So for Titiler, so we provide like a demo endpoint. Well, I just posted a link for you to try Titiler. But so development is a service company. We don't sell product. We sell like my time, basically, or my colleague times. And so our goal is not like for you to use this demo endpoint or like for you to pay us to run to use our service, because and it goes like really deep. So everything I build or we build at development, we try to build it as a way that everyone should be able to deploy themselves. And so, and I believe that Titiler is really easy to deploy. And so that's why I will not feel comfortable for people to pay us to use Titiler that XYZ, because I believe it's really easy for you to deploy your own, and yes, to own the cost of that. But I do hope that people can deploy their own Thai server easily and use it, and not having to use a third party thing like mine, where you don't control the things. I could run analytics on your usage of Titiler that XYZ. We don't, but we could so. I just I hope that we build open source tools that are really easy to use. And if the documentation is not great, please feel free to help me on the contribution side. But we hope everyone can use that. And Kushan, feel free to use Titiler.xy. Everything you do is great. So I'm really happy that all the demos that you built on top of that is great.
Thank you so much. I think you make so much easier. So for people deploy on the AWS and Lambda, so it's great. I think the only problem that for regular users, most of them don't really have the expertise of using AWS to deploy. So I really wish that Google or Microsoft, somebody can have some kind of demo endpoint rather than development C have to be responsible for that. Of course, the planning computer, they have the endpoint, but you need to render the data on their planning computer, not outside. And for me, I mean, it would be great they have, but I just don't want to have the burden of those startup companies to pay the bill, because I'm doing the tutorial. I want to show people how to use it for disaster management. But in the meantime, I feel a little bit guilty because I don't want to be responsible for the bill, because I don't know how many people want to use that. And so right now, there's no really those big tech that hopefully AWS, for example, open data, they have a demo endpoint anyone can use. That would be great. So in that way, I don't feel guilty about the bill that development C has to pay. I'd rather Google, Microsoft, or other big tech companies can take it over. But thank you very much. Like I said, you guys are my heroes that I benefit a lot from your work.
Awesome. Thank you so much. That was great. We have 2 minutes. If someone has one last question, we can take that. Otherwise, thank you, Vincent and Jed, for coming and taking time to present at the working group. Tyler.
Hey, something I wanted to ask a question of Vincent. I actually sort of asked him before, but would like to hear. more of a description of the flexibility of Titiler to run the custom computations. Like what are the parameters of what's possible? I understand that per pixel is okay, time series, neighborhoods. What is currently possible and what's on the roadmap?
So good question, as always. So we include like simple band math expression capabilities in Titiler. You also have ways to add your own custom algorithm, like following like some really simple application specification, but then it means that you have to deploy your own Titiler endpoint. But then you can do whatever you want within your custom algorithm. So it's called custom algorithm within Titiler environment. But like you can do a lot. Like it's basically Titiler is just a simple wrapper on top of ThreoTiler Python module that access the data, and which is a wrapper on top of a rasterio GDAR. So it's really extensible. You can do a lot of things, and I hope I build it in a way that it's really easy for anyone to extend and customize their own like Titiler application. So yeah, you are looking at like the custom algorithm, and you can hope do a lot with that.
Thanks.
All right, thank you so much. I hope you had a great time, and we'll see you in the next call. Thank you all.
Thank you. Take care. Bye-bye.
Bye. Thank you.
Thanks, everyone.